If we are building a web server, it definitely will have several routes. And in this tutorial, I will show you how to set up a basic routing in ReactPHP application. So here we have a server setup. It responds the same way to all incoming requests regardless of the path and method. Now let's replace this code with two endpoints. One for GET request and path tasks, and one for POST and the same path. So the first one returns all tasks, and the second one adds a new task to the list. Also for all other requests, we return a 404 not found. For simplicity, tasks will be stored as an in-memory array. To detect the current path and method, we use a request object. If the requested path equals tasks and current method equals get, we return all tasks as a JSON object. Create a response with 200 status code, application JSON, and encode our tasks. And import them here. In case of POST request, we need to write some logic. We expect a new task from the request body. If there is a task field in the request body, we extract it, store in tasks array, and return 201 response. If there is no such field, we consider it as a bad request and return an appropriate response. Status code is 400 and an error message. The last step is to add a default 404 response and remove these comments. Now let's check that our routing works as expected. Start the server, and here I have a list of all possible routes. The first one is a list of all tasks. Got it. Then we try to add a new task. It works. Then a bad request to add a new task, and then a request to a wrong route. So everything works. But you can see that even with two simple endpoints, the code already looks messy. And while the application grows with new endpoints, the code will be in a real mess. So let's figure out the way we can refactor it and make the routing a bit cleaner. The callback with our logic is a middleware, and the way we can refactor it is to extract a middleware for each endpoint and then pass this middleware as an array to the server constructor. Let's try this out. The first middleware lists all tasks. Create a function with request and a callable next. Then just copy this code here and continue chaining to the next middleware. The second middleware adds a new task to the list. Again, create a function, copy the code, update if statement, and call the next middleware. And the last one is not found response. New function, but this time without any arguments and no tasks variable. Just return a response. Now we can replace this callback with an array of our middleware. List all tasks, add new task, and not found. And the server should behave as before. Start the server and let's check that our routing still works. List all tasks, create a new one, bad request, and 404 response. This approach with middleware may look cleaner than placing all the code in one callback. But now all middleware have this path and method checks. It actually doesn't look like routing, just several request handlers. It is not clear what route goes where. We have to look through all these handlers to collect a complete picture of the routes. To remove this mess with path and method checks, we can use a real router, for example, Fast Route by Nikita Popov. Let's install it. OK, the main idea of using a third-party router is to take this path and method checks out of middleware and move them to the router. This will clean out our middleware from conditionals. Also, we can remove callable next. The next step is to create a dispatcher with a simple dispatcher function. To define the routes, we provide a callback with router collector as an argument. Also, we need our middleware here. Then we use the collector to define routes. It looks like this. We specify the method, the path, and the request handler for each route. Here we define two routes, to list all tasks and to add a new one. And now the most interesting part, dispatching. We need to somehow match the requested route and receive back the corresponding handler. So we remove an array of middleware and replace them with a callback. The dispatcher has just one public method dispatch, which accepts a request method and a path, and returns a plain array. The length of this array may differ, but it always contains at least one element. The first element of this array represents the result of dispatching. It can be one of three possible values. All these values are defined as constants in dispatcher interface. Here they are: not found, found, and method not allowed. So we dispatch the route and start checking the result. In case of not found, we return a 404 response. In case of found, route info array contains the second element. It is the request handler, which was previously defined for this route. In our case, this handler is a middleware, so we can execute it with a request object and then return the result of this execution. Let's remove this middleware, we don't need it anymore. And let's check that still everything works as expected. We start the server and here is my file with requests. Get the list, then add a new task to the list, a bad request, and a 404 request. All routes still work fine. But all of them are very simple. The real application will definitely have routes with wildcards. Let's say that we want to receive a certain task by a specified ID. As an ID of the task, we use its index in the tasks array. If there is a task with a specified index in the tasks array, we return it. Otherwise, we return a 404 response. How can we implement this? First of all, we need a new middleware for viewing the task by its ID. As a second argument, it accepts an ID. Then we use it as an array index and return a task. Then we add a new route. Use a new middleware, method get and a path. Notice that a new route has a wildcard, which means path tasks followed by any number. But this is not enough. We need to somehow extract an actual task ID that was passed within the path. All matched wildcards and their values can be found in the third element of our route info array. It is an array with wildcards and corresponding values. For routes without wildcards, it will be empty. So we fill the call of the request handler with all matched wildcards values. OK, the route is done and let's check that it works. Start the server and create a new request for it. Copy this one and let's request the first task in the list. Change the description and run the request. Done. It returns the first task. Let's add a new task and then request the second task in the list. Run the request and the server has returned a newly added task. So, when building a web application on top of ReactPHP, you can face a problem with defining routes. In case of something very simple, you can just check the path right inside the request handlers. But when you are building something complex with many different routes, it is better to add a third-party router and let it do the job. In this particular video, we have touched Fast Route by Nikita Popov, but you can easily replace it with the router of your own choice.